mouse is still not clicking. I can right click, but I cannot left click. I guess Microsoft can now say Microsoft Windows is better than Linux. No, it's working now. Strange. Uh-oh. Well, fortunately, that part only shows whether people are here or not. There we go. So we got the scores over here, and then we'll take a look at the breakpoints. Doesn't want to do it that way. I have to spell it out. 5/8, 5/8, 7/8. And we have 60 points to the whole thing, so you multiply 60 by the ratio. So 7.5 points is the breakpoint for an F. Anyone getting anyone getting less than 7.5 points is equivalent of getting a letter grade of F. Anywhere between 7.5 points to 22.5 points is equivalent to a D. 22 to 37.5 points is equivalent to a C. 37.5 to 52.5 points is equivalent to a B. Anyone with 52.5 points or more is getting an A, or equivalent to a letter grade of an A. So when you look at the grade distribution on this side, you will see that we have 1, 2, okay, let's see how many people have A. We have 6 people getting A's. Okay, we have 6 people getting A's. How many people getting B's? We have a lot of people getting B's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12 people getting B's, 6 A's, 12 B's. How about C's? C's are from 22.5% points to 37.5 points. So let's see. Scroll. So we got 1, 2, 3, 4, 5, 6, 7, 8. 8 people getting C's. And how about D's? These are from 7.5 points to 22.5 points. That would be, let's see, well, we only got one person getting a 0. Or am I looking, yep, that's the right one. Okay, so we got 1, 2, 3, 4, 5, 6, 7. 7 people getting D's, and apparently one person is getting an F. Okay, so that's the grade distribution. You can see it is centered around a B. 6 people got A's, 12 people got B's, and 8 people got C's, 7 D's, and 1 F. So as a class, it's doing fine. I mean, there's no problem that I can see. Any questions about the scores?
You just graded last night?
And this morning, yes.
Yeah, because yesterday was like 20 points.
Yeah. Yeah, yesterday I only got the first question graded. So last night I tried to grade as many as I can. At 11:30 p.m. I just could not grade anymore. I just could not focus anymore. That's really abnormal for me because usually by 11 a.m. I just start to work at 11 p.m. Okay, so at that time usually my mind is it's just warming up. But yesterday was really bad. I had to go to bed, so I woke up at 5:30 this morning to finish the grading. So are there any questions about the grade distribution? You have to remember the grade distribution of this class, how the grade equivalence is different from most other classes. Most other classes, will start a D at 60%, in this class, we don't do exactly that. Okay. Any questions? Any questions? And I try to give partial credit whenever partial credit should be assigned, but apparently it doesn't help everybody, but it does help certain people. Okay. So let's see if I can. Does anyone know the shortcut to get back? To go back in history. I can always go here and then right click. Backspace. Well, at least this got me back. It's just doing very slow,
Maybe you have to restart the whole thing.
Nope. I don't have to restart the whole thing. All right.
That's a lot better. It's a lot better.
A lot better, yep. Okay. So last time we started to talk about arrays already, and if I go back to the files from last week, I can see exactly what we talked about. And last time we talked about finding the maximum. We talked about array initialization, and let's see, in the text file, we talked about the algorithms that relates to arrays. We kind of evolved our. Oh, I forgot to give you the assignment, didn't I? The array, the algorithm to find prime numbers, to fill up an array with prime numbers. We talked about it, but I forgot to give you the actual assignment. So I can give you the assignment today. Just a few cases. Give you an array of 3, fill it up. Okay, it's not really that bad. What are the first 3 prime numbers? The first one is given, is 2. The next one is 3, and the next one is 5, right? So, it's not going to be a big deal if I give you an array of 3 elements and ask you to build it up. So that should not be, a very difficult assignment. It's a good exercise, though. It's a good exercise because this thing has almost everything that we need, including, pre-checking loop, post-checking loop, a loop inside another loop. It has array indexing. It has the mod operator. So just about everything that we have talked about other than pre and post conditions is here. So that would make a really good, worthwhile, homework assignment. It's not going to be very long. In terms of the trace, it's not going to be very long because most of the time the innermost loop will complete without even one iteration. Only for 5 it will go through one iteration because 2 times 2 is less than 5, but then 3 times 3 is greater than 5 already. So we're not really looking at a lot of iterations, but it does, serve as a good example of all the stuff that we have learned up to this point. Do we have any questions about, this particular algorithm? No questions? Okay. If there are no questions, we'll proceed and talk about, how do we find an element within an array? How do we find a particular value inside an array? In other words, I can give you an example on the whiteboard like this. If I have an array, A bracket 0, A bracket 1, and A bracket 2 have the values of 5, 2, and 7, which means this array is not sorted. Does everybody understand what I mean when I say an array is sorted or not?
It has to be in order.
Exactly. When an array is sorted, then the elements have to be in a specific order. In this case, it is not in any specific order because 5 is greater than 2, but 2 is less than 7. So the ordering of the elements, of the neighboring elements, is not consistent. There's no particular order to it. Now, when you have when you have an array that is sorted, you can use much more efficient algorithms. But when an array is not sorted, you cannot use some of the more efficient ways of sorting through the array. Okay, let's say I want to find the value 4. In other words, K represents the value that I'm trying to locate in the array. I'm asking the question, is 4 one of the values of the array A elements? What do you think?
No.
It's not. How did you find out that it's not? Which algorithm did you use? Yep, exactly. You used the eyeball algorithm. Okay, because we can scan 5 to 7 just without thinking about it and say, oh, none of those is 4, and make our conclusion that way. So this is not a very good example of how do you search for a particular value when you're dealing with an array that is not sorted. So one good example of searching for an item in a particular thing that is not sorted is a dictionary. And then someone will say, but the dictionary is sorted. Well, but what if I tell you that I just want to find a word, not necessarily the definition part, but not necessarily the word being defined, but also in the definition part, and I want to find the first occurrence of that word ever in the dictionary. That means it is not going to be a quick search anymore. In other words, if I want to look for the word smile, okay, yes, definitely, if you look for the definition of smile, the word smile is on that page. But that may not be the first page where the word smile appears in the dictionary. So if I want to ask you to find the first occurrence of the word smile in the dictionary, that becomes a tough problem. Because now not only do you have to look under the words being defined, but also the definitions of every single word and scan for the word smile. How would you go about doing that? Not including giving up. So people just say, I give up, I don't want to do it. Yep.
As a source?
Well, you have to do some kind of exhaustive search, right? Okay, you cannot use, any heuristics and say, okay, we know it cannot be in this part of the dictionary. There's nothing you can rule out unless you have scanned that particular page. So now you have only a few choices. You can scan from the back all the way back to the beginning. You can scan from the beginning to the back, or you can scan randomly. How would you do it?
The beginning.
From the beginning to the end. Very good. So we want to scan from the beginning to the end. In this case, we are scanning from the first element. We compare that to the value we're trying to look for. No, it's not the same. We move on to the next one. We compare this to the value we are looking for. No, that's not it. Move on to the last one. You compare 7 to 4. They do not match. And then you move on, and then you find out, oh, there's no more. Now that I have looked at every single element and none of them has the value that I'm looking for, I can now conclude that 4 is not the value of any of the elements in array A. So are we getting a fairly general idea of how to do a linear search? This is called a linear search because we are looking at the items in a sequential fashion. So is the general approach okay? Do you guys understand the general approach of linear search? The next thing we want to do, or the next thing I want to do, is to try to write an algorithm to accomplish exactly that. So what I would usually do is I will not give you the exact algorithm to start with. I'll give you, a step by steps. Okay, how do I come up with the algorithm? Okay, we'll just say that this is linear search algorithm. Do you think the linear search algorithm involves a loop? Are we doing something again and again?
Yeah.
We are. Okay, so let's start with that. So we have loop and loop. And then whenever we have a loop, we have to think about, do we want this loop to be an infinite loop?
No.
No, not in this case. Okay, very good. So we have to specify an exit condition.
Is there
How?
a case when we want the infinite loop?
Sorry?
Is there a case when we want the infinite loop?
It depends on the application. Most applications do not have an infinite loop, but a lot of times they have, loops that are pretty close to infinite, like the event handling loop of a Windows or a GUI application is almost infinite because, you have to keep looping until the application closes. But closing an application is something that you can do